Hey everybody, it's Mr. Mott. What we're going to do is go through that second row of our precipitation lab. I've got the bottles turned sideways so you know what I'm adding here. On the vertical here, I guess we'd call it, this is our potassium phosphate solution, 0.1 molar. And all these solutions are 0.1 molar, which kind of goes along with our table of solubility. These are a good indication, our table of solubility is a good indication about when a precipitate will form. And we're going to kind of go with that. In AP Chem, we do talk about the fact that this is a little bit concentration dependent. All right, but here we go. What we're going to do, I'm going to take my potassium phosphate, and I'm going to add a couple drops of it to each of these, okay? And then I'm going to add my different solutions to them and kind of mimicking that sort of grid motion that we have with our table of solubility. All right. Now at this point, it's always good practice to kind of predict whether a precipitate is going to form, and then we're going to see if in lab it actually matches that. All right. So add a couple drops. That one looked like it's getting kind of cloudy, which is what we would predict. Barium chloride next. And then lastly, we've got our copper chloride. Now, if a precipitate is going to form, generally it's going to happen pretty quickly. And if I kind of block some of the light coming in, you can definitely see precipitate forms in each case. Sometimes by the if you're doing a more complicated lab like this, you can use the color of the precipitate to help identify what the precipitate is. But for this particular lab, all we're looking for is when we make a prediction using our table of solubility, does that match what we actually see in lab? And for each of these solids that formed, the table of solubility would predict not only that a precipitate would form, it also tells you the identity of that precipitate. All right. Thanks for watching.